Hi everybody, today we're going to be talking about chemistry. First things first, vocabulary. You should know what all of these words mean by the end of this lecture. So if you need to, stop the video and write them down. We're starting at the beginning. Elements. We talk a lot about elements in biology. Most frequently we talk about carbon, hydrogen, and oxygen, but we also talk about other types of elements. And elements are just atoms that have characteristic behaviors and certain structures. An atom is the smallest amount of an element you can get. You can't divide it into any smaller particles without losing those characteristics and predictable properties. Atoms are made up of three different kinds of particles. The first one is protons. These are positively charged and they're found in the nucleus. Neutrons are also found in the nucleus, but they don't have any charge to them. And electrons are negatively charged, and they are orbiting around the nucleus in things called shells. So you can see here, hydrogen has one proton and one electron, and carbon, even though it's got more stuff, it's the same arrangement. The protons are in the nucleus, and the electrons are orbiting around it in shells. Now in this case, because we have more electrons, they can't all be in the same shell. There are rules about how many electrons can be in each shell. The innermost shell can only have 2 electrons. After that, the next couple of shells like to have 8 electrons in each of them. Atoms are very happy when they have full shells. In a neutral atom, the number of protons equals the number of electrons. So the number of positive charges equals the number of negative charges. In the case of our carbon molecule, carbon has 6 protons and 6 electrons. The atomic number for carbon is going to be 6 because of the number of protons it has. An atom cannot lose or gain protons, but it can lose and gain electrons. What happens when an atom gains or loses electrons? When the number of protons doesn't equal the number of electrons, we call that an ion. And there's 2 different kinds of ions. So if an atom loses an electron, it's lost something that's negative. It will become positively charged. That's called a cation, a positively charged ion. If an atom gains an electron, it becomes more negatively charged. We call that an anion. An anion is a negatively charged ion. So if you look at our picture on the right here, you can see that we have a sodium atom. It's in green. Sodium atoms usually have 11 protons and 11 electrons. However, because of our special arrangement in the shells, we have 2 electrons in the inner shell, 8 in the next shell, and then we only have 1 electron left over for our third shell. It's not very stable. It doesn't like to be alone. It wants 8 electrons, and there's only 1. In that case, sodium can lose an electron. It's lost something that's negatively charged, so it becomes a cation. Where does that electron go? Well, it goes over to another atom, maybe, in this case, chlorine. Chlorine has the opposite situation. It normally, in a neutral atom, it would have 17 protons and 17 electrons. But again, because of the arrangement of the shell, chlorine is only going to have 7 electrons in its outer shell. It's not happy. It wants another one. Well, lucky for it, sodium is nearby and may donate an electron for it. So sodium will become the cation, positively charged, and chlorine will become the anion, negatively charged. Now remember, atoms can gain or lose electrons, but never protons. We've talked about electrons and protons, but we haven't really talked about neutrons yet. Remember, neutrons have no charge, and they're in the nucleus. This number can be equal to the number of protons or not. When they're not equal, when protons don't equal the number of neutrons, we call this an isotope. An isotope still has a neutral charge because the protons and electrons still balance out, but it's a little bit heavier or lighter depending on whether it's lost or gained a neutron. To review, can an element change the number of protons? No. Can an element change the number of neutrons? Yes, it can. When it changes the number of neutrons, it's called an isotope. It can still be neutral. Can an element change the number of electrons? Yes, it can. We call that an ion. When an ion is formed, it is either positively or negatively charged. Something that loses its electron becomes more positively charged, and we call it a cation. Something that has gained electrons becomes more negatively charged, and we call that an anion. Let's talk about valence electrons. Valence electrons are the electrons that are in the outermost shell. Let's go back to carbon. It has 6 protons and 6 electrons, and because of the arrangement in the shells, 2 of the electrons are in the inner shell, and only 4 are left to fill out the outer shell. And again, how many electrons do atoms want in their outer shell? They want 8. So in this case, carbon only has 4, which means it either has to get rid of 4 electrons to be happy, or get 4 more electrons to be happy. That's a lot of electrons to get rid of or gain. So carbon is unlikely to form an anion or a cation. It's much more likely to share electrons with other atoms. However, when we talked about sodium and chlorine, they're much more likely to take or give away electrons, and so they're going to form different type of bonds than carbon would. The situation with carbon, where it wants to share its electrons with another atom, would be a covalent bond. And this is forming between 2 atoms that want to share their electrons. You can either share a single pair of electrons and make a single bond, or you can share 2 pairs of electrons, and that would be a double covalent bond. You can even have a triple covalent bond, and that would be 3 pairs of electrons. And as you share more and more electrons, the bonds get shorter and shorter and more rigid. But again, a covalent bond is simply a bond between 2 atoms that are sharing the electrons. Now there's 2 ways to do that. One is that you share the electrons equally. Each atom has a similar electronegativity to the other atom. Electronegativity is just the ability to attract electrons. So if you look at the top picture, the 2 kids are equally sharing the earbuds. They're listening to the music, and there's really no big difference between them. On the bottom, however, you can have unequal sharing. Now, these 2 kids are sharing the ice cream cone, but it's not really an equal share. He's holding the cone. She doesn't get to have her hand on it. So he gets to choose how many licks she gets versus how many licks he gets. And it probably won't be equal. So a polar covalent bond is when the atoms are sharing electrons, but they're sharing it in an unequal manner. Let's look at a picture of this. You have 2 hydrogen atoms. Each one of them is the same. They each have 1 electron that they would like to share. They come together to make a hydrogen molecule, and the electrons are equally shared between the 2 atoms. In a polar covalent bond, however, you have different atoms that are sharing electrons. In this case, we're looking at a water molecule. So you have an oxygen and 2 hydrogens. They're sharing electrons. The electrons want to be near the oxygen, and so they end up hanging around on the oxygen side of the molecule more so than they end up on the hydrogen side of the molecule. So again, to review, nonpolar means the 2 atoms are either the same or very similar in electronegativity. A polar molecule means the atoms are different in terms of their electronegativities. All covalent bonds means that they're sharing electrons. An ionic bond, however, is different. This is when an electron is completely transferred from one atom to another. If you look at the picture, look at the girl on the tricycle. She's not sharing. She's going to take that tricycle away, and the little boy is going to get nothing. This is the type of bond that happens when you have an ion and a cation. Let's go back to our sodium and chlorine atoms again. Remember, our sodium atom had 1 valence electron. It really wants to get rid of it. So when it gets rid of it, it forms a cation. When the chlorine atom takes that electron, it forms an anion. Once that happens, the positive and negative charges will attract one another, and a bond will be formed. This is an ionic bond. Let's go back to the water molecule again for a moment. What kind of bond do hydrogen and oxygen form? They're sharing electrons, so that's a covalent bond. But they're sharing them unequally, so that would be a polar covalent bond. This is a very special situation because the electrons are going to be likely to be concentrated on the oxygen side of the molecule and less likely to be over on the hydrogen side of the molecule. And remember, electrons are negatively charged. So if you have more of them on the oxygen is going to have a slight negative charge to it. And the hydrogen is going to have a slight positive charge on it. And what happens in this situation is if it gets together with another molecule of water, there's going to be a flirtation between the negatively charged oxygen on our original molecule and the positively charged hydrogen on one of the new molecules. This results in what's called a hydrogen bond. Hydrogen bonds are represented by dotted lines, which helps us to remember that they're not true bonds. They're just temporary attractions. This happens when hydrogen is bound to either nitrogen, oxygen, or fluorine. And again, this is because all three of those elements are very electronegative. So they can pull the electrons away from whatever they're covalently bonded to. And this all happens because they make polar covalent bonds with hydrogen. This bond is temporary and it's very easily disrupted. However, when you have lots and lots of hydrogen bonds, you can actually make large structures, such as DNA has hydrogen bonds in between the base pairs of the two sides of the ladder, and proteins are initially folded up using hydrogen bonds and the attraction between hydrogens and oxygens in proteins. A couple more terms for you today. Hydrophilic. Hydro means water. Phil or phile means love. So these are water lovers. These are polar molecules or charged molecules that like to be near water. Hydrophobic, however, phobia means hatred. These hate water. These are nonpolar molecules, things like fats and lipids that do not like water. And the last term is something called amphipathic. These are molecules that have both hydrophilic and hydrophobic region. And the reason we care so much about phospholipids is because that is what makes up the cell membrane in all cells. There's an area where the phosphate group is that's charged, that's hydrophilic. It likes water. And there's an area, the two tails, that are just carbons and hydrogens. That does not like water. That's hydrophobic. Those are nonpolar. So if you put these in an arrangement together, they're going to form this lipid bilayer that makes up the cell membrane. But that's a topic for another day. Hope you liked chemistry. Have a great day, and I'll see you in class.